this lesson is on the index laws, and we will be doing examples with numerical bases. So our bases will be numbers. Now, our first index law, so index law 1, involves adding powers of the same base. Now, write these steps down if you haven't got them already. So the first step is check for any negatives. And remember, an odd amount of negatives is going to be negative, and an even amount will be positive. And this is when we are multiplying or dividing. Okay, that's a trick we can use. Step 2, write down the different bases you see. And step 3, you just add the powers of the same base. So if we apply these steps, it'll make it much easier when trying to work out the first index law. So let's make sure we understand this index law. Over here we can see we have our bases are A, so we have A over here and A over there. They are the same bases, and we can see they also have powers. And just to recap, a base is the bigger value. It could be algebra like A, or it could be numbers like in this case 2. So if I have 2 to the power of 3 over here as an example, my big number down here is called the base. And my little number up there, is called the power. Or you can say index number. Okay, so when I refer to base, it's the larger number on the bottom. Now, with the first index law, it says add the powers of the same base. So I've got the same base. So to show some working out and to show how this index law works, write down the base. All right, so there's my base, A. Just write it down once. And now add the powers of that same base. So I've got 5 plus 3. And 5 plus 3 leaves me with 8. So if I had a similar question, but I changed my bases, for example, if I had 2 to the power of 5 times 2 to the power of 3, I can see my bases have changed, but I am still doing the same thing. Write down the base. In this case, it's number 2. Add the powers of the same base. 5 plus 3 is 8, and I've got my answer. So you can see what is happening. The bases do not change. I still have my A there. I still have my 2 there. What is changing with this index law? It is those powers, okay? Those index numbers. They are the only thing that are changing. Now, just in case you are wondering how this index law works and why we add the powers, always go to a basic example. And for example, 2 to the power of 3, if I was to expand this, so if a question said expand this, I would have 2 times 2 times 2, okay? And I know how to work out 2 times 2 times 2. So if I evaluate this to get an answer, I will have 2 times 2 is 4 times 2 is 8, okay? And that's how I work it out. But if I want to do more of an investigation, and I said, okay, what if I started with 2 times 2 times 2, and I want it to go back into index form. I want to see a power. How did I get that 3? Well, we know there are invisible powers. In this case, there's an invisible 1 above all these 2's. Every number has an invisible 1 as a power. So for these 1's to become 3, that means we have to add them. That's the only way we can get those 3 1's to become that 3. So we end up with 2 to the power of 3 because we have actually added the powers of the same base. So we have actually been using this index law when doing questions like this without actually realizing it. Okay, so I want you to have a go with these 3 questions, which involve the first index law because we are multiplying everything. And I want you to simplify it, not evaluate, which means leave it in index form. So have a go first. Okay, so with our first question, have a look. Your first step is, I don't see any negatives, so there's no need to count negatives. Next, check your bases. I can see the bases that I have are all 9. So I only have one type of base. So my base, I'm going to write that down, is going to be in my answer. I will see a 9 there. Now, all I have to do next, my third step, if you remember, is to add the powers of the same base. Don't forget that these 9's have an invisible power 1. Okay, now add up all these powers. So imagine there's a plus there. So 4 plus 1 is 5, plus 1 is 6. So you should have had 9 to the power of 6. Now, number 2 may have confused you, only because you can see there's a decimal and there's brackets. Now, inside the brackets, there's nothing we need to do. There's no multiplication, addition, and there's no powers inside the brackets. So the brackets are just there to say that the power of 1.8 is 3, and in this case, the power of 1.8 is 5. They're just highlighting that. So technically, if I had this 1.8 to the power of 3 times 1.8 to the power of 5, it's actually the same thing. So the brackets don't really need to be there, so don't let the brackets confuse you. Now, what is my base? Well, the base that I see is only 1.8. There is no other bases. So 1.8 is my base. So remember, bases can be any number, decimal, fraction, a whole number. And now add the powers of the same base. What is 3 plus 5? 3 plus 5 is 8. So I'll put brackets. I'll leave my brackets there because the question had brackets. So that's my answer. Now with our third question, it is starting to look a little bit more complicated, but it is just as easy as the other ones. Follow those steps. Now I can see why in this case, because I have negatives. So my first step is, let's take care of the negatives. Is the whole thing going to be positive or negative? Well, I'm going to count my negatives. 1, 2, 3. 3 is an odd amount, which means my answer is going to be negative. That's my first step. So you can get rid of your negatives now or cross them off because we have dealt with them. Next, your next step is to look at the different bases you have. I can see now I've got different types of bases. There's a 2, there's an 8, and there's also a 5 over here. So we'll write down the bases from smallest to largest. You don't have to, but that's the way we do it in maths. So I'm going to write 2, but please write times in between them, because if you don't write times in between them, if I have, for example, 2 times 8, it'll look like 28. So when we have numerical bases, you have to write the times down. So 2 times, and then my other base is 8, and I have a 5 over there. I'll write 5 first, because 5 is smaller than 8, and then I'll write my 8 there. Do you see any other different numbers as our bases? No. I have a 2, a 5, and an 8, and that's it. And now my final step is to add the powers of the same base. Start with our 2. So I've got a power there, that's 1, and a power there. Now I think the previous question may have had a 3 here. So I'll change it to power 3. I'm pretty sure I wrote it down wrong. So imagine there was a power 3 there, sorry. So I've got 3 plus 1, which is just 4. Okay? And if I made a mistake writing it down the second time, you just check your own answer. That's fine. You just add the powers of the 2. And now my 8, this has a power 10. Oops, sorry, it disappeared. And that has a power 1. What is 10 plus 1? That is 11. If it helps, cross off the bases once you've used them. So that I've used my 8s now. And I'm left with this 5 to the power of 3. There are no more bases with 5, so it stays the same. The 3 doesn't change, and that's my final answer. Don't forget it's a negative, and I've got my bases there, and their powers have changed. Now, just one more question involving the first index law. You can see I've put this question using algebra. Have a go, because remember, you're doing the same thing. Add the powers of the same base. So, what different bases do I see? I see an A and I see a B. I'll keep times there for now. When we actually learn algebra, the times can be invisible. And now add the powers of the same base. I've got 2 plus the 1, which is 3. And I'll cross those off. And now my base here is B. So I've got 3 plus 10, which is 13. And that's my answer. If you had this A to the power of 3 and then B to the power of 13, that's also correct, because the times is invisible. But we will learn that when we do algebra. Our next index law involves subtracting powers of the same base. And this is when we see division. So I forgot to mention index law 1 it involves multiplying bases. In this case, index law 2 involves dividing bases. So I'll just put dividing in brackets, because we're going to see that. Okay, so to see how this index law works, I can see I've got the same base as A, and I can also see that instead of times now, I have division. remember, division is the opposite to times. So when I was multiplying, I was adding my powers. So in this case, instead of adding, I will be subtracting. And that's how the index law works. So to do this example, I would have A, it's my base stays the same, and now 5 take away 3. So I am now subtracting the powers. And 5 take away 3 is just a 2. Now, the other way of writing this question, we know that division can be also written in fraction form. So I can have a to the power of 5 divided by a to the power of 3, but it's in fraction form. You do the exact same thing. Remember, you start from the top. So always start from the top and then you subtract. So 5 take away 3 also leaves me with power 2. Now this can get a bit more complicated and there are other ways of approaching this, but at this stage we are just subtracting. So 5 take away 3 is 2. Okay, so try these first two questions using the second index law. Now with this one, once again I can see I've got the same base. In this case it's a 4. So my 4 will be in my answer. So I can write the 4 down now. And then 6 take away 3 leaves me with 3. So I end up with 4 to the power of 3. With number 2, same thing. I can see I've got a base 2 and a base 2 that's there. So I write my 2 down to get it ready and I subtract. Now be careful with your negative number skills. I can see I have a small number. 2 is smaller than 10. Whenever you start with a small number, your answer will be negative. So you should have had a negative. And then 2 take away 10. Well, normally, what is 10 take away 2? 10 take away 2 is just 8. That's the difference between them. So you should have had negative 8 as your answer. Now, later on, probably next year, you will learn how to turn this negative into a positive. But at this stage, you were just applying the index laws. So that's correct. Okay, so try these questions. We are still dividing. They are just written in fraction form. With our first one, I can see my base on top is 5 and as well as the bottom. So 5 is my base. And then I'll just go 10 take away 2. 10 take away 2 is just 8. Nice and easy. Number 4, I can see my base is a 3 on top and bottom. So I'll write down my 3. And then I can see I've got 7 on top, which is smaller. So I will have 7 take away 10, which leaves me with a negative 3. So I hope you had a negative 3 there. Now, with our fourth question, you can see that this one has the same base, but also the same powers. And we've actually learned how to do this before the index laws. What I mean is, if you see the same thing on top, for example, if I have 13 on top and 13 on the bottom, because they are the same thing, we basically divide it with with each other. So 13 divided by 13 is 1. 13 divided by 13 is 1. So the trick is you just cancel out the same thing on top and bottom and you're left with 1. So with number 4, without even knowing the index laws, you can just say, okay, I've got the exact same thing on top and bottom. So I'll cancel it out and the whole thing will just be 1. And that's one way of doing it, and that's correct. But now that we know a bit of information about the index laws, let's explore this. If I wanted to use the index law, well, I know I have to subtract. So if I write it out again, if I use the second index law and I subtract, same base, I'm dividing, this will equal, I'll just do it up here, 2 is my base, 3 take away 3 leaves me with 0. Now, we have in class learnt what this equals, but just in case, just imagine you didn't know what that is, okay? So what is 2 to the power of 0? Imagine you didn't know. A way to work it out is, well, I can work this out. I have worked it out one way. I've got 1. But another way is, okay, if I have 2 to the power of 3, I know 2 to the power of 3 is 2 times 2 times 2, which is 8, over the same thing on the bottom. And I can see what's happening. 8 divided by 8 is 1. So that's why 2 to the power of 0 is 1. That's another way of looking at it. So let's move on to our next index law. So our third index law is anything to the power 0 is going to be 1. Okay, so try these two questions. And remember, anything to the power of 0 is 1. Okay, so to do these ones, your first step is, for the first one, I can see if I apply BIDMAS, index numbers come first, powers come first. So I have to cancel this. 2 to the power of 0 is just a 1. So I'm now left with 1 times 3. And 1 times 3 is just 3. So you should have had 3 as your answer. With number 2, once again, I can see I've got plus here, not times. That's okay. My index, my powers come first. So 2 to the power of 0 is 1. 5 to the power of 0 is 1. Let's write it out now. I've got 1 plus 1 plus 10. So 1 plus 1 is 2. And then 2 plus 10 is 12. So you should have had 12 as your answer for that one. The next index law, and our last one for this session, is index law 4. And it's saying raising a power to another power. If that confuses you, this index law, you will use it when you see brackets, okay? That's when we apply this index law. And the only thing you have to remember is this. Multiply the power outside the bracket with every power inside the bracket. So let's do some examples to have a look and see. So to see this index law, we can see in my brackets I've got a base, which is A, but that's fine, it's still a base. And it has a power 5 inside the bracket. Outside the bracket, here is my power 3. So the index law says you multiply the power outside the bracket, in this case it's 3, with the power or powers inside the bracket. In this example, I've only got one power inside. So I'm going to put a times there because a lot of students, they make a mistake and they add them. They go 5 plus 3. You don't add them, you must multiply the powers. So I end up with my base stays the same, and I end up with 3 times 5, which is 15. And that's how the index law works. So always do an arrow and a times to remind yourself that you are multiplying. Okay, try these two examples first and have a go. So with the first one, we can see we have brackets and there's a power 8 out here. So all I'm going to do is multiply this power with every power inside. So I'll just go, do my times. So 8 times 4. My base is 7, and then 8 times 4 leaves me with 32. Done. Now don't evaluate, we're just simplifying these questions. With number 2, now there are two parts to this. I can see brackets here, but then I've got times 2 to the power of 3. Now just like the index, like BIDMAS, we'll do our brackets first, because brackets come first. And now in my brackets, I've got 2 to the power of 3. So my base is 2 in the brackets, and I'm going to go 4 times that 3. So times the power 4 with the 3 inside the brackets. 4 times 3 is 12. Now don't forget to write down the rest of the question. Times 2 to the power of 3. And now you can see what's happened. We now have to use the first index law we learned. Do we have the same base? Yes, I can see my base is 2 and my base is 2 here. If I see the same bases, I add the powers of the same base. So write the 2 down, and then 12 plus 3 leaves me with 15. Okay, so this one actually involved applying 2 index laws. One was getting rid of the brackets, and the second one was then simplifying by adding the powers. So sometimes we have to combine index laws, and we'll do some examples of that in a minute. Okay, so now try this one. Remember, just multiply every power with the power outside the brackets. So inside my brackets, I can see I've got 2 different bases. I've got a 2 and a 5. That's fine. The power out here is a power 2. So I have to always use arrows so you don't forget. I have to go 2 times the 7, but also 2 times that 3. Every power inside the brackets gets multiplied by that 2. So I get my bases ready. So 2 times 5 is what I'll have. They're my bases. And now let's multiply the powers. 2 times 3 is 6, and 2 times 7 is 14. Now let's check. Do we have the same bases here? 2 and 5 are different. So I stop there. I can't add the powers, 6 and 14, because they belong to different bases. So the next part of our lesson now is doing questions that involve combining index laws. So doing more than one index law in a question. All right, so have a go at this question first and see how you go. There are different ways of approaching it, but we'll do it the way that we've we've learned the index laws today. So, if I have a look, I don't see brackets. So that's okay. I don't see negatives, but what I do see here is power zeros. So let's do that first. Anything to the power of 0 is just a 1. And also down here, there's a power 0. I can do that first. Next, if I look at the top, I have a base of 3 here and a base of 2. And on the bottom, I've got a base 3 and a base 2. So I'm just going to write it out again. Now, on top, I can't add the powers of the same base because they're different. 3 and 2 are different, and as well as the bottom. So now I'm going to use the second index law where I subtract the powers of the same base. Now work with one at a time. So I have, ignore that. I have base 3 and I've got 5 on top and 2 on the bottom. So I'm going to write my base down, which is 3, and then 5 take away 2 is just 3. So I'm working with one at a time. I'm doing that one first, and then I'll be doing this one. In between them, I still have a times. And now my base here, so I've got 2 to the power of 2, and then 2 to the power of 1 on the bottom. Don't forget that 1's there. So 2 take away 1 leaves me with 1. And that is my answer. I can write it like this because I know the 1 can become invisible. So this one here was a bit more tricky because we had more than one base on top and bottom. Just work with the same bases and do one at a time. Okay, so with our next question, we can see we have a division, a fraction line, but also there are brackets. So take care of your brackets first, just like with maths, brackets comes first. And so let's use that fourth index law. All I'm going to do, if I have a power outside the bracket, I times it with the power inside the bracket. I'll do that on top and bottom. So I'm left with now 2 to the power of, well, 4 times 3 is 12 over 6 times 2 is 12. So I've still got the same bases. 2 hasn't changed, the powers have. Now I can see I have the same thing on top and bottom. So I can just cancel out and the whole thing is going to be 1. If I wanted to use the index law, well, I would have my base 2. 12 take away 12 leaves me with 0, which then 2 to the power of 0 is 1. So either way is correct, but I guess we are using the index laws, so we could have used that one in our answer. Okay, so this can be our last one for this session. Now, don't be scared of this question. It's actually the easiest one we've done out of the last two. So have a go first. Now, if you remember, when we see brackets, we'll take care of those first. Now, on top, I've got a 0 here. And if I multiply everything with the power 0, I will be left with, if I just do some working out here, 2 to the power of 0 times 2 to the power of 0, which will leave me with, well, that will be a 1 times 1, and I end up with a 1. A trick is, whenever you have a power 0 outside the bracket, everything in the bracket is going to become 1. That's a shortcut. So you can do it the long way and show working out, but cross it off and put a 1, because everything we can see will equal 1. And then on the bottom, I've got a bracket. So 3 times that 2 is going to be 6. So I'll stop there and write down what I have left. I have on top 1 times 3 to the power of 5 over 3 to the power of 6. Okay, so I'll continue it up here. Now that 1, I don't have to write that 1. It can be invisible. So I just have 3 to the power of 5 over 3 to the power of 6. And now apply that index law where we subtract. My base 3 will stay the same. And then 5 take away 6 leaves me with a negative 1. And that's your final answer. So keep practicing the index laws. They can get tricky at first, but the more you practice, the easier it gets. Thank you.